This is a system we've come up with in order to aid these severely paralyzed patients in their communication process. By looking at 8 predetermined different directions, users can select different characters and therefore communicate their intentions and thoughts across. Let's have a look at the system. This is the virtual keyboard. That's the style of the system. Since we only have 8 different inputs, in order to ensure that we have the maximum number of letters or outputs available for a user, we make use of a matrix-style keyboard. Basically, every character is controlled by a row number and a column number. Every number, be it row number or column number, is controlled by these 8 different directions. For example, let's look at the letter D. D is in row number 3 and column number 4. In this particular system, number 3 is controlled by a down movement and number 4 is controlled by a left movement. Therefore, users first look down to select row number 3, followed by left to select column number 4, thereby selecting the character D. The green buttons that you see at the corners of the screen tell the user where to look in order to select his particular direction. Therefore, let's say he wants to select 3, he looks to this green button down here. To select 4, he looks to this green button to the left. To let the user know when he should start moving to his desired direction, we have this move button in the middle. When the move button turns green, users are indicated and told that they can now move to their desired direction. When users move to a particular button, the button will light up and the selected row also lights up to let the user know what he selected. So now you select 3 to select the row number 3, and then users look to the left to select 4. As you can see, the letter D also lights up in a different color to indicate to the user the character that he's chosen. And D gets printed out in the display panel. Some of the benefits of this system are that because we make use of this matrix-style keyboard, we see that the layout actually follows the most common letters first, followed by the least common letters. So we see this is different as compared to the current implementation, which make use of a normal QWERTY keyboard, where your speed of typing or communication is dependent on where your letters are. In this particular case, no matter what letter you want to choose, you always only have 2 eye movements, and therefore a very constant speed, which is faster, can be obtained through using this system. These are the electrodes that we make use of in order to obtain the eye signals. Now I'm going to show you a demo of the system, where I'm going to type out the word hello.
Stroke is the leading cause of disabilities all over the world. According to the National Stroke Association of Singapore, about 10,000 people are admitted in Singapore hospitals due to stroke every year. The numbers are several hundred thousands in UK and US and rest of the globe. Now, about 2/3 of these stroke patients do survive and require rehabilitation as well as communication aid. Majority of the stroke patients can only move eye voluntarily. Any other part of the body is not under their control. So in this project, we aim to develop a communication tool that will help stroke patients to type a letter or email by using eye movements.